Hello everybody, another installment of our building a REST API using Phalcon v6, and so far we have good progress. We managed to connect to the database, get some records, do a user get, but we still have quite a bit of work to do. What we're going to be doing today, time permitting of course, is reorganizing the repository in a little bit of a better way so that you guys can understand the pattern and make sure that everything is being presented or exists where you expect it to exist. We're going to work a little bit on the JSON responder to finesse the payload that we're returning back. This is a custom payload that we decided that we're going to use. Of course, there's plenty of other implementations such as OpenAPI or others. We're going to work with our repositories, transport repository, query repository. This is a little bit more further down in this video. We're going to introduce a security class so that we can store passwords hashed in the database. We're going to work on our enumerations, and also I want to be able to create a JWT class, the class that will create and also validate JSON Web Tokens. If we have time, we're going to try and do an authentication / login service, but we might have to wait for the next video for that depending on time. So let's have a look at the organization of the repo as I mentioned. This was primarily my fault, getting carried away and putting things where they shouldn't be. We discussed that we want the ADR pattern, and the pattern is action domain responder. So that is what we should be looking at our folder, the SRC I mean. So the responder should really be here in the top. So now we have domain and responder. And our action should be again at the top. Again, action handler and action interface. And I really love the fact that PHP Storm just does all this refactoring for you without you having to worry about where things would be. As far as the ADR is concerned here under domain, I'm going to bring everything from the domain to the ADR. I mean, there's no point in having a domain under there. I'm going to get rid of this. So now we have action domain controller. All right. I want also a distinction between the components of the application and the services. If you recall, we have a user service and we have a hello service. We're going to have more than that. So I want those to be in one location and everything else to be in a different location. So what I'm going to do is I'm going to create a folder called components. And in here we're going to dump the constants, data source, exceptions, interfaces, middleware. And these services, of course, we're going to drop in the container, and then these three. All right. And as far as services are concerned, the hello service and user service are the two candidates that need to go in there. So our folder structure is now action domain responder. Under domain we have some things for the ADR. We could put these in the components side of things, and also we can have them somewhere where for instance the input interface we can put, and domain interface we can put them in the interfaces folder here. Let's leave them for now over there. I mean, it wouldn't hurt. So Now that we've done this, we need to make sure that everything is fine. Test unit coverage HTML, and we have errors. Okay. We see we have a parser. Let's have a look at, it says env factory, so it will be components env factory. There you go. That use. Let's run the test again. So far so good. Composer analyze. No errors. Excellent. So I don't know about your IDE. Certainly every IDE has its own strengths and weaknesses and all that stuff, but in this instance PHP Storm came out with flying colors. It did manage to refactor everything, change namespaces where it should have, and we got the files exactly where we want them. Now let's have a look at our response, and also let's have a look at our responder. So what our responder is doing is it picks up a payload, the results from that payload, it sets them in the response, renders it, and then a response is sent by this middleware, the response setter middleware. If you recall, we added that as a middleware that is running at the end, the finish. So we're sending the response as soon as everything is done. Now, this one means that we're going to have a custom response class. And that's all good, but I don't really like messing with the response. So what we're going to do is we're going to move this functionality inside the JSON responder. Right? So what we need to do first, and this is a precursor to what's going to happen, is just copy these types, these PHP stand types, into the responder types. So now we have them as a copy here, if you like. So tdata, terror, and so on and so forth. As far as the JSON responder is concerned, we need to copy some code from the response itself. Of course, the calculate meta and the init payload. So here, let's paste them here. We don't need anything else from here. Let's do num, get this. Let's get the payload out of there. And we can put it here. Now this payload and this payload will clash, so let's call it content. That would work. Now we need to do this calculation, calculate meta, and what we're going to do here is we're going to have an array of payload contents, payload. Contents, and we need response interface. Actually, not even do that, just the contents, and it will return array. Let me take this out, and I'm going to put it up here. So the calculate meta will need what? need an array. Okay, let's think about this. Okay, the best way to approach this is to make the result of the payload object mimic what we have here. So the result itself, the get result, should be an array that contains data that we can use here. Let's make a slight change to the original plan, and we can certainly optimize this to our needs. We're gonna check the code, message, data, and errors. And you're gonna see also why we're doing code, message, data, and errors in a little while when we go to the middleware. So let's get the code. Code equals result code, or HTTP codes enum. Okay, value, and that is a string, an int. We need message, and that one will be HTTP codes enum. Okay, text. That's a string. We need the data. Result data this. We need the errors. And we also need the status message. What will we say? What will we have here in this line? The message success. This one here, this message, is the message that gets returned in the response. It's the one that we use with set code when you're setting the code. So status message equals true, empty, errors, and that will be success or error. Now, good thing we got all that. Let's just reformat the code to have a little bit of clarity. But we need some more data from the responder types. That's why I moved stuff here in the responder types. We need the T data and T errors. This for PHP stan, of course, so that it understands what we are getting back. Alright. So now that we have all these, we need to create our content here, our content payload. So this one will be data. This one will be errors. The code will be code. And this one down here will be the status message. Okay. It's gonna be interesting with this because we don't have the e tag. Alright. I guess we're gonna have to pass the response in the method so that it just sets it in there. Would have been nice if we had the e tag back. We might do it. Alright, so let's do content, comma, e tag equals this calculate meta content. Alright, so that's what we're expecting. We're expecting an array with a content and an e tag. And this one will return a response payload. Alright. So you're gonna return, let's see, array. The first element will be int, let's say 0 will be the response payload, 1 will be string. And we need the other brackets, these ones. And what we're sending inside is the T-response payload. It's this one here. And it's content. Okay. So this one is content. Okay, we're calculating everything. Let's bring this reference in. SHA1, and then it's payload. Oh, no, it's not payload, it's content. Like that, and then you will return content, comma, e tag. Alright, so we're coming over here, we're picking up the content and the errors, we'll do it in our calculations here, we're setting the meta timestamp and hash, and we're returning the content and the e tag. And right here we have content and e tag calculate meta. And so now what we need to do is, first of all, response set header e tag equals e tag, and then we need to do the status, set status code equals $code message, set JSON content equals content, and finally send. So let's have a quick look. Whenever we get a payload object from the domain, we expect to get a code, a message, data, and errors. And we're checking all these and we're parsing them, and then we're creating the output JSON that we want. We populate it, we're doing the meta calculations, and then we're sending the response back. Now for this guy, if I refresh, I do see resource not found. If I go to the beginning, I have a problem. It says here response already sent. And this is fine because we still have the middleware response sender middleware active, and that one is running at the very end of the request and is trying to send the response, which we already sent from the responder, and that's why you have headers already sent. So if we delete that guy, and we also go to I'll need to delete the test too. Services. I need to reorganize these too. Where do I have the test there? HTTP, yeah. Response? No. Middleware. There you go. Response sender middleware. So get rid of that guy. And then we need to go to the routes and remove the middleware from the finish, this one, and actually go to the container and remove it from here too. Remove the references. So now going back to our browser, if I refresh, I do have hello and success. Okay, now the problem is we don't have the data or errors here. We don't have the hello world that we were expecting. That is because we're not returning back in the payload what the application is expecting. This is a change we just made. Okay, So if we go to hello service, let me close the container for instance, for a moment. We're expecting code, message, data, and errors, right? If we go to the services and then go to the hello service, if you see here we have results, and that's not what we want anymore. We want data here. And the same thing with a user. This one will be data, and this one will be errors. Now, if I go back to the browser and I refresh, now you see hello world. And that's how this little change was made. If we go again back to the browser and type health, you see it gives me message OK, service operational. Okay. Now, we did say that we want to remove the functionality of this response, all this. We want to remove it from here. And as a matter of fact, we want to remove this class also. The response types, we already copied it to the responder types, and the response, we just don't need it anymore. So we're going to delete those two. And what we're going to do is in the container, you see now this response doesn't exist. We're going to use the Phalcon response. Okay. And of course, now the minute we start running tests, everything's going to break. Clearly it breaks because the interfaces are not correct, and the classes expect a different the certain classes are using the response, and they're using the methods that we had implemented there, but those methods don't exist anymore. Alright, so for starters, let's go into the action and the action handler. Now let's have a look. This one is fine, but the action handler here, it asks for the response. So what we're going to do is we're going to get rid of the response, get rid of the request, and change it to their interfaces. Request interface and response interface. And also, if you see here, this complains as well, the responder and everybody. So the input class is expecting a response, a request, excuse me. So we're going to put request interface here and fix this too. Alright, there you go. Now we're complaining about the responder. Let's go to the responder interface first, and we just need a response interface here. And now in the JSON responder, all we have to do is just change the interface to match response interface. Let's have a look. There we go. It was the import. Down here everything is fine. So we had 6 errors, 4 failures. Alright, we're getting somewhere. Alright, so now we have all these things here that with code doesn't help and all that stuff. So that's so far so good. We made significant changes, but the application didn't completely break. All we have to do is just arrange the middleware so that it follows the same sending, if you like. So the health middleware here, as you see, has a payload and calls halt. The not found middleware, it calls halt as well. So the magic will happen here in the halt. Let me get rid of these two guys because we don't have them. And as far as the PHP stan, if you recall, we moved these definition to responder types. There we go. responder types. Okay, so now in the hold, we have to do just a tiny bit of work to get everything working. So response interface is this one, and we need the responder. Application get service container responder JSON responder. Now we're stopping the application, which is great. Our responder, if you recall, accepts a payload object, domain payload object, that has success, failure, whatever, and then an array of results. So we need to simulate those results, send those results to the responder, and let it send the request on its own. So the results that we need are, we will need code, message, data, and errors. Sometimes the autocomplete really loves me. So this is our payload. This is the meat, what we want to send. Okay, and we already have that information because we passed it as code, message, data, and errors. And now you understand why we're using exactly the same structure in our payload object, because we want to take advantage of all of these here that are coming from a halt operation. So we're going to create a new payload. And in here we're going to have domain status. We're going to put success because it is a success. And results. So that's our payload. And all we have to do is call the responder, invoke with the payload, and when you get rid of all of these. So this one will run it. Oh, I forgot. Yes, it needs the response. There we go. So all the previous calculations and all that stuff go away. We just create a new array, a new payload object, and we just send it to the responder. If I run this again, we had 4 errors, 4 failures. Now we have 2 errors and 4 failures. And this is primarily from the renaming that we did, because it looks for results, and the results doesn't exist. You only have data. And also here in the main services, the response test with payload data. Now here's the interesting part. We got rid of the response, so this test can actually leave by means of delete. So now if I run it again, I'm only going to have the ones that cannot find the results. So user service test will be here, and we need to enable the dispatch as well. So assert array has key errors, because that's the when you get an error. With user ID will be data here, and then data, and this one is what? Records not found, so that's an errors. So if I run this again, I should have less, just one. Hello service test. Data errors, data errors. This one will be data, data. There we go. Also, I forgot, I do need to reorganize this as well, the same way that we reorganized above. So I'm going to create a new directory action, and I'm going to create a new directory responder. And under domain, we're going to create what we discussed, components. Just shrink this. Components. And in here we're going to have the data source. These guys, as well as the middleware. And in the services we're going to have the user and the hello. And hopefully it did everything properly. Excellent. Let's run scan. Okay, we got router provider. Okay. Router provider needs this one to go away. This one will go away. And what we need to do is request interface, response interface. And now everything is running fine. Again, composer analyze. Perfect. So we made several changes here with regards to the structure of our repository, and everything is working fine thanks to the refactoring options that PHP Storm offers. Otherwise we would have to do this by hand and go and check every single class that we had to do, that we have. I will be adding more tests, especially for the action and the responder. It's always nice to have tests for every single component and not rely on, let's say, one dispatch test that would make everything work the way you would like to. So let's talk about the interaction with the database. If you recall, last time around we managed to connect to the database and we created a class to go and ask the database for certain pieces of information. That class was the user repository under data source. It's this one here. This user repository class is connecting to the database, grabbing some data and returning it back to whatever we asked it for. However, this one does two things. It not only picks up the data, but it also returns everything as user transport, which is the domain object that the plain PHP object that we decided to transfer domain information back and forth. I'd like to split this in two different classes, and also create a class, a repository class, that will be able to proxy creation of these classes, the user repository and whatever else we're going to have. And this way we're going to have one registration in the DI container, and from then on we can just access whatever we want. So for this user repository class, what I'm going to do is I'm going to copy it and make it a query repository. That's how I'm going to call it. And it's not going to be final. And what we're going to do is we're going to have, we're not going to have a constructor, but, or actually we do, because we need the connection, don't we? Let me just put that there. What we're going to do is we're going to have a property here that we will store this class so that we can use it whenever we want to. And we're going to make it so that it's always reusable. Okay. So what we need here is a private user repository as user. Now, this one will act a little bit as a factory, and what we need to do is here public function user, and we'll give you a user repository. And we're gonna say if null equals this user. This user equals new user repository with the connection. Return this user. So this method here acts a little bit as a proxy to this class, and then we're able to access it by calling the user method here, this one. And now we need to go to our container and make the necessary change. And our container, let me just reformat it. With this reformatting that I do, there's certain there's certain rules that I've set to PHP Storm, and it sorts everything automatically, alphabetically. So when I want to run something, when I want to get something, when I want to format this, all the constants are being alphabetically sorted. As such, the little visual that I want to create here, where the common services are all the way at the top and the ones that we created are a little bit at the bottom, just breaks. So this is why I have to redo this again, which is fine. I mean, I don't mind. Okay, so what we need to do is we need to figure out the repository, and what we're going to be calling and storing there, for that matter. So what I want to do is I want to get rid of this repository using just let it as repository, because the repository is going to be kind of like the superclass that would allow us to get what we need. Repository is there, get service repository, and then somewhere down here it says get service repository user. Gonna get rid of that, and this one will become query repository class. And also down here, the get service user get, that one is expecting a repository user. So in our services, this one, if you see its constructor, it expects the user repository. And what I want to do is I want to send it the query repository. So I'm going to change here the signature. Let's call it repository here. I'll come back to this in a second. In the container, all I have to do is just change this to send the repository in. But here's the difference in the actual service. Now that I have the query repository, this one becomes this repository. Let me just clone it so that you guys can see. Repository, and then user, and then on the user, find by ID, user ID. So that's the difference between the first line and the second line. The main thing is that I would have, if I was to do more operations here with different tables and all that stuff, I would have to pass each and every one of them in there. But by just now passing one repository, I'm proxying everything to different methods and so on and so forth. So this one works a little bit better in terms of future construction and operations of our application. Okay. Now that we got this, now that we have this query repository, it's a little bit weird because in the user get service, we're getting this user, and this user is a user transport, so it's defined by ID. Okay, so if you look, not this one, it's this guy, we're returning a user transport. But if we want to split this, whereas this thing never returns a user transport and just returns the array of data, then we're not bound by this particular transport, we can change anything we want in this abstract in this layer of database layer, and then using an array we can manipulate it the way we want to, any way we want to, really. So I would like to change this defined by ID so that it returns just an array. Okay. So again, in the user repository, I'm going to do find by ID, and then this is going to be array. And what we're going to return here is the T user record. There we go. And then return result. Clearly our application will break now because we're expecting a user repository. Oh, sorry, a user transport. Let me just close this guy. Hello. User service test, leave that open. User repository test. We can work on this in a minute. I have too many files open. The joys of doing mass refactorings. So, in the user get service, what we got here is now an array, and if we want it to be a user transport, we have to create a new transport for this user transport. That's what I meant. So how can we do that? Well, if we create a class that would be able to fire up all those methods to create a new user or a new login user or a new company or a new whatever, different transports based on what we want, and we have that class in our container, then that would be pretty much the same as the query repository, where we have one class as a central point and we just pick everything up. So let's do one class here as a transport repository, and this one will not have constructors, won't have anything. It will just accept normal, and we could make it read only. We don't really mind. So all we will have to do here is just create a new user. Let's see, where's the, do we have this thing? T user input? No. Alright, let's write this down. So we need PHP stan import type T user record from user types, and then this one will return no, the parameters here will be array db user, and it will return back a user transport, and this array will be the T user record. Get rid of this, and all we will do is return new user transport db user. So with just this method we're going to be able to create new transports, and let's send this guy to let's register this guy to the DI container here, and then we have repository transport, and of course, since this is a simple class that gets created and it doesn't have any constructor parameters and all that stuff, we can just put transplant repository class here and it will create it on its own. We don't really have to. Now I don't believe that we will need to have this shared, but if we do later on, we're gonna have to change it to be registered in the DI container so that we keep the resources low. So now that we have this repository transport, the get new user service changes slightly, because what we could do is we could inject it in here and we can have fun with it. So private transport repository as transport. And actually, let's send the filter one as well, because we have it registered, but we haven't used it. So this user gets service. If I go back to my container, user service is here. Okay, so we have a repository. We're gonna do repository transport, and we're gonna do filter. So all these are gonna be injected. So the first thing we need to do is to see what do we need with a filter, and this is the easiest thing we can do. Filter ABSint of the input user ID or 0. And if that is greater than 0, we're gonna say db user equals find by ID, user equals this transport, new user, db user, and then all I have to do is just say user to array, and that's it. That's all I have to do. So we split this into two different lines. One line grabbing the data from the database, and the other line transforming it to a transport where we can use it. Now, of course, if I run the tests, it's not gonna like it. Primarily because the find and all that, he cannot find the repository user, right? So we're gonna fix that next. We're gonna go and fix the tests. Now let's try and fix this test. This one says repository user. This will be repository, and this one will be query repository. And this one over here will be user, find by ID. And let's also pick the transport repository. Transport. And this one will be repository transport. And of course, these ones do not work because the user is a database user, and the user as a transport, new user, db users. That should make it work. Nice. Let's have a look at the analyze. Excellent. So we split those two. We made the transport repository, and from the transport repository we can create different objects that will be moved into our domain back and forth accordingly. And of course it will utilize the user transport and other transports that we might have later on for companies, invoices, whatever our application will start. The same thing with the user repository and the query repository. Those two are going to be binding together. What I want to do now is I want to make a change in the users table, and this will be in preparation in preparation for the JWT tokens. If you remember, our table just has 4 fields and a couple of indexes, and we want to enhance this to increase it, if you like, so that we can have more fields to store information. So the way we're going to do this is by means of migrations. And if you recall, the migrations are located here under Resources, DB Migrations. And we're handling those migrations with things. So in order to check, we're just typing thing status. We see that we have one migration, add users table, and nothing else. But we want to create one more in order to change our table to have those more fields. We're going to call it add more fields to users table. And if you notice, this one is camel case, and then it makes it snake case, the actual migration file, and it puts the date on it. This is how it ensures that there's a uniqueness. So it should be down here, and if you recall, there's nothing wrong with the change method, but I prefer to do up and down. So up will run when we move the migrations forward, down when we roll back. Also, the way I do things here is a little bit different. I tend to drop indexes and then drop the fields that I don't want to, and then add the fields that I do want, and then add the indexes. One can certainly do this in more than one migration, or they can just wrap everything together in a big operation and then put save. It doesn't really matter how you do it. It's whatever you guys are comfortable with. I'm just going to choose one way of doing this. So table, the table is going to be called CO users. So we're grabbing the table object, and here we need to remove the indexes first. We're going to remove the status flag, and we're going to remove index as well, USR username, and then we're going to hit a save. Then we're going to remove the field, and we need to hit save on this. And now the username is gone. What we're going to replace it with is an email. That's a more appropriate field name to check. Usually it's emails. Also, I'm going to add more fields, and what I'm doing here is I'm copying from my test environment on the side, and I'm going to paste it here. I don't want you to get bored with seeing me type 100 different fields. So let me explain what we're going to do. We're going to add a new column called user email. It's going to end up after status flag. You see this after. This is a wonderful feature that MariaDB and MySQL supports. You can inject a field right after a particular field, allowing you to keep the most important fields at the front or at the top of your table, and then some other fields at the bottom. Unfortunately, other RDBMSs don't support that, so if you really want to add a new field, it will always go at the end. And if you have many fields, then you have to be scrolling left and right just to find where things are. So this one will be 128. It's a little bit of an overkill. I think 64 would be fine. I'm trying to put everything in powers of 4. Then we have a username prefix. That's Mr. Mrs. The first name, middle name, last name, and suffix. And these ones here, the issuer, token password, and token ID, are going to be used for the JWT stuff. The token ID will be unique for every user. Of course, the email will be unique as well. And then we have the preferences. I thought might as well put a field here to add any preferences that a user might have. That could very well be a JSON string that will hold anything that we can think of. For instance, we could work with the user and just say, all right, your tokens will expire in 4 hours instead of 2 hours or whatever. So customizations like that. And the last four are fields that I prefer putting them there. So we have created date and updated date, created user ID and updated user ID. And that gives you a little bit of logging in terms of who did what into your database and who updated your records or created your records. As far as indexes are concerned, we're going to add a compound index between email and status flag, because that's going to be checked pretty much all the time. So we have to find a user by email, and then we have to make sure that the email and status flag are correct. Usually we're gonna check if a user is active and if the email is correct. That's the main query. Then we might check the user ID and status flag. I just put that there. Of course, the user ID, the token ID will be there, and unique is true. And actually, let me, instead of putting a status flag here, let me put email, another, or no, we have the unique here. That's fine. Actually, it's not fine, because in this instance we might have the same email and different status flags. So let me remove the unique here, leave that one there, and I'm gonna create another index down here, not the status flag, user email, and that one will be a unique. So we're gonna have an email that's gonna be unique. A token ID will be unique as well, and then those compound indexes are for searching purposes. And this will be my up, what I want the database to become. On the down part, we're going to do the reverse. And let me copy and paste everything. Saves a little bit of time. So what we're doing here is this one needs to be email. What we're doing is the reverse. So whatever we did at the end of the up, we're doing it at the beginning of the down. Again, we're picking up the table, then removing index by name. So I email X status, this one here, then this one, and this one. So removing those indexes. And then just shrink these for a bit. And then we're starting with the columns. So you see all these columns over here. We're just saying remove these columns over here, and then save again. And then finally, we want to revert back to this version, and we want the username. So we're adding it again after the USR status flag. We're adding the USR status flag index, and then we're adding the username. If you remember at the beginning, we removed those two indexes, and then we removed the field. So now if I run the migration, which will be Finks status, there you go, there's one migration that says down, it hasn't run. If I run Finks migrate, it run, and if I come here to my database and refresh, you're going to see the brand new fields that were added, as well as the emails that the indexes that were added. And with that, we have a lot more flexibility in our database. So that changes things quite a bit. Here, for instance, this test is not going to be working very well because we don't have the username and so on and so forth. As a matter of fact, if I run the test now, it's going to complain heavily that the username field does not exist, like that. So let's go for now and work a little bit with our tests, because we do need to make alterations into our test class. It's the abstract unit test case.
as well as our migrations. So let's do the migrations first. It's this user's migration that we need to work on. Of course, we change things, and now we have to make sure that they're fine. Before we do that, in the abstract migration, I remembered we don't really need the get table because we're accessing the table as a property. So might as well get rid of that. And here for the insert, what I'm going to do is I'm going to copy and paste it and explain. Um, this change here came from Copilot, which was a really cool change. It actually told me, hey, you need to use PDO and the relevant bound parameters instead of just the straight up insert. It didn't matter that much because this is testing code and we control the data, but it's always good to keep good practices. So I just pasted how the migration should look. So if you see now, we have a lot more fields, ID, status, email, and so on and so forth. The insert, which is pretty straightforward. And down here, we're preparing everything. We're getting all these things together, and then we're executing it. If there's a problem, we do it. And the difference with the previous migration is now we're returning an ID or a number instead of a boolean. So that's our migration here. It will run on the CO users table. And if we go now to the abstract unit test case, we're going to have a couple of changes that we need to make. So for starters, what I want to do is I want to make things a little bit easier for us. Let's see, do we have a setup here? We do not. Okay, so first and foremost, I want to create a container here all the time. So every test that runs will have a container object in it. It is a little bit of an overkill, but it helps us tremendously from instead of creating a new container and all that stuff. So protected container is container like that, and then public function setup. I don't know if there's anything in the parent, but it's okay. And then this container equals container. So our container will always be here. And what we want to do is we want to check these classes, these functions. So the asserts are fine, but what we want here is to get the connection. And the connection it's this variable here. The connection will be taken from the DI container. Get connection equals connection. This connection, and it will be connection equals this container get shared connect container connection, and this one will be a connection object. This connection equals connection, and return this connection. So what we're doing here, we've done this 100 times before. We're grabbing the connection from the container, we're storing it into the property, and then we return the property. And if we call this again, the property is already populated, it will return the same object. We could have done this directly because the container will always return to you the same object, but it's perfectly fine to do this little tiny optimization. As far as the get new user is concerned, it's working with the migration. Of course, the migration changed. We need to get rid of this set connection. It's no longer needed. We leave the get from database and so on and so forth. So what I want to do is I want to have a way to generate random data and also create a user array of random data. So the randomness will come from a library called Faker. So let's install that. And of course, we're installing it in the dev side of things. And what we're gonna do here is we're gonna have a method get new user data array fields, and we'll return an array. And in here we're gonna have a faker object create. Let's get the password first. It's gonna be fields use our password or a get strong password. And then the return would be this array over here. I'm not gonna bore you with typing. I've got it already here. So we just need to import the dates. So what we're doing here is if whatever I pass in through here, it will be used. If I don't pass anything, some defaults will be used. So if we assume that we don't pass anything, the status flag will be 1. User email will be an email that Faker sends us. The password will be either our get strong password or something else. Same thing with the token password, token ID, and so on and so forth, and of course other Faker data. So that's our get new user data, and the get new user here changes slightly because now we don't have to create anything here. The get new user data will do it for us. So user data equals this get new user data, and then throw the fields in there because we have the option to add a field from here when we're creating the migration. And then user ID equals migration insert. Let's get rid of these things here, and let me copy and paste all the fields that we need. They're gonna be here, and then this one will close there. So this is what we want to pass. And the insert, if you remember, it will return the last insert ID. That was the change that we did. And we want to get from the database CO users the user ID equals username, user ID. And then that will return the DB user back. So this change here allows us to populate the database with random data and all that stuff. So we fixed the migration, abstract migration. Let's move on a little bit on the tests as well. Of course, we're going to see errors. I expected. It says .env setup must be public. Yes. This is because we introduced a setup method in the abstract class, in the abstract test unit. So we do have a setup here, and we had it as protected. So what we're going to do is we're going to call it public. And now that they're same, we could use we could call parent setup here, and that will create the container. We don't necessarily need it, just leave it as is. I'm not sure if I have anyone here. Maybe the env manager. Yes, I do have one here. It's another one, so we're gonna go public here. So that should allow at least everything to run, and we will have errors, of course. Okay, it complains about the user repository and the user service. So let's have a quick look here. User repository, of course, has this set connection. We don't really need that. And now we have to correct this. We have to remove all these containers. So in the tests, let's go and find new container, and then open and find window. And here in the container test, do we need this? We could leave it as is, and then we can just say container has container events manager. I'll leave it like this because um, it might not be obvious that there is a container that's been created in abstract unit test case. Granted, by running this test, we're creating two containers, one that the abstract unit test case creates and one here, but we can leave it for now. It's fine. On this one, we don't need this guy, and we need this container. And again here, this container. And again here, this container. And that's it. In the health middleware, we're just gonna get rid of this. We're gonna say this container. Leave the health middleware the way it is. Same thing with the not found. There we go. And we have one here. Should we change a little bit? No, it's fine. I was thinking maybe we can take the not found middleware from the container, but it's fine the way it is. We'll just leave it. As far as the error handler provider is concerned, we're going to do the same thing. We're going to make sure that the container comes from the abstract class, and we have one here, and we need to register things on it. There we go, and we should have one more somewhere here. And then this, and also we need to throw it in there. So the router provider test, we can do this, and then this, and then this. So these are our containers over there. Hello service. There you go. And of course the user service. That's done. This one will be container. We don't need the set connection. We've already addressed that. And this one does the connection. Okay, so I'll look at these. Okay, so I need to make another change. I know I got an error somewhere here. Let me quickly see the hello. That's fine. Okay, in the user service here, why is it complaining? Expected field name. Oh, I made a mistake here. Okay, so in the user get service, this one should be container, and that's empty. In this one with user ID, I don't need the connection because I already have it like there. I have this utility method. If you recall, I put it in the abstract unit test case. Of course, I could have left it the way it was. Just get the shared service, the connection from the container. But since I have this utility function, might as well use it. And this one should be fine. All right, so let's run this. Of course, we have an error. Okay, it says username and then test service with ID. All right, so far so good. It's working okay. This one here, it says user repository test find. Return value must be of type array null returned. All right. So let's go to the user repository test, and we're gonna have to make some changes here because we added a lot of fields. So what I'm gonna do is I'm gonna make changes here. This one will become by ID. We don't need the connection because we can get it directly. So let me just do we have the run assertions? No. All right, so let me do this first. Private function run assertions, and it will be array db user array user. This will be void, and what this method will do is it will grab both arrays, the user and the database user, and I'll explain what those are, and it will compare them one by one. So let me paste all this code here. So you see the DB user, it checks the user ID, and the user, it checks the user ID. And this method now changes as follows. We need the repository, which is fine. We don't need this transport. We're going to make a different, we're going to create a different test for the transport repository, so that will be fine. So this one will be this get connection. And then we don't really need, actually, do we? Yeah, let's test the empty. So what we're gonna do is we're gonna have a user, and then we're gonna send 0 to it, and then this assert empty db user. So this top part will tell us that records not found because the user ID is 0. Then we're gonna have a new migration, a brand new user. We want to find the user with its user ID, and now we don't need to do this. We need to do this run assertions db user and user, and that will check every single user that we have. Of course, I made a mistake somewhere here. I put the DB user too many times. All right, so this one will be a user. That's how we're gonna call it. It's the what comes from the transport. Actually, no, registry user makes it a little bit easier by just putting different names. All right. This one will be migration user. So we want the migration user to be the same as the registry user. So that makes it a little bit easier. What we're doing is we're creating a new user using a migration. That user comes straight from the PDO and the testing framework. And then we're calling in the repository the find by ID here to give us the, it's not registry, it's repository, sorry. There we go. That makes it a little bit precise. There you go. So that one allows us to do that. Now, also in this find by ID that we have here, I'd like to enhance it a little bit. And what we're going to do, because this one is coming down the line, we need to create a find by email. Because remember, we're going to be sending an email to the logging in order to get an authentication token. So let's create that method now. And before we do that, I want to create a central way of having data. So we're going to have parameter will be array here, and then string, and that one will contain boolean or integer or string or null, and it's going to be called criteria. And then it will return to user record. It's going to be a public function. I already have it. Find one by, and this one will be array criteria. And what we're doing here is we don't need these ifs. Select, new select. We're going to do where equals, and this one will be criteria. And we're going to return the result. This is a feature of the select. So where equals, you pass a key value array. The key is your field, and the value is the value of the field. And what it does is it uses AND, and it just search for everything that you want and creates the where condition. So by having this, the find by ID changes a little bit, because what I can do is return this find one by, and in the criteria all I have to do is user ID equals user ID. So that shortens our code a little bit. And also let's add the one that I mentioned, the find by email. This needs to be public. Of course, this one will be email, and it will be a string. And of course, here we need to do email if it's not empty. For this, should we do? Let's do a different. Find by ID should be if it's greater than 0, because it's a number. Actually, it's string and number. Should we cast it before this? Let's leave it integer, just integer. And here, this one will be USR email equals email, but also USR status flag equals 1. Arbitrarily, I'm just saying 1 is active. We're gonna come back to this in a little while when we work on the enumerations, because this will be replaced by an enumeration. Okay, so in the user repository test, let's have a look at what we can do. We have test find by ID. Now we need to add the test find by email. It's going to be a similar test, of course. So find by ID, this one becomes find by email, and then we're going to send an empty string, and we're going to assert that the repository user is empty. In the user ID, we need to put email here, and we're going to get the migration user USR email, and then here it's going to be find my email, and then email here. And let's have a look what we've done. All right, excellent. The user repository is perfectly fine. We have a problem with a user service test, which shouldn't be that difficult to fix. So we have the dispatch here. I'd like to fix that in a little bit, but let's have a look at the empty user ID. So we have get service, invoke, not found. This is errors. Okay, that's perfectly fine. The with user ID is the one that we're gonna have changes, right? So db user is that the migration user, give us the user ID, call the service and invoke user ID is this, and then the domain status will be success. And now, okay, the problem appears here because we don't have all the fields. So let me just copy all the fields that we're checking. Give me just a moment. And we're gonna copy from this actual data here. Paste all of it, all of these fields. Let me check the next method, records not found. Okay, that's good. Let me enable the dispatch as well. Just get rid of that. And I'm gonna make a slight alteration so that it works as well, because we haven't touched this test in a while. I mean, I think it was from the last stream. So okay, let's get the migration. Let's create a migration rather, and then this get connection. Okay, db user equals migration. Oh no, sorry. This get new user, and then we're gonna throw the migration at it, and then user ID equals db user ID. So now we know the user that it's in the database. What we're going to do is we're going to issue a get. We're going to issue it in the user URI, and then the get will be user ID equals user ID. And now in the env manager, we need to import it. Okay, we're getting the data, assert has key data, errors, blah blah blah. And then what we need to do is we're going to do something a little bit different. So the errors are empty, so this is the key here, what we need to check here. And just get rid of these. So what we're going to do is we're going to get the data back, right? And the data will be in a format, if you remember, with the user transport. Let me find it. Domain. If you recall here, the user transport has a lot of stuff in it. Alright, and one of the things that it does is when it returns that stuff, it returns the ID and then the contents of all of this. So that is what I expect to get back here. So in order to simulate that, I have my database user. So what I'm going to do is I'm going to create a new user transport. And I could have easily used the transport repository to get that from here, right? I might as well do that actually. Equals this container get container repository transport. All right. So down here, what I need to do is I need to say my user equals transport new user db user, and then expected equals user to array, and then actual equals data, whatever was returned from the data array, this one here, and then of course this assert same expected and actual. I'm not sure if this one would work because you probably noticed the user transport doesn't have everything, so, and it does have username, so it's not going to be perfect, but it's gonna work a little bit. All right, excellent. It does say you don't have the email, right? So the next thing that we need to change is the actual transport. We need to add the fields that we need to have in there because of the change that we made to the database. I'm not going to bore you again with typing a lot. What I'm going to do is I'm going to copy and paste at least the stock block. And you see now we have a lot more methods that we can take advantage of. And as far as the constructor and everything else, let me just quickly do a copy paste here. And let me explain. To array, again the same, we haven't changed it. It will return the ID, and then the contents. Is empty checks if we have a 0, and if the 0 is in the store ID, so meaning empty record. I'm introducing this new method here called getFullName, which will get the last name, first name, and first name and middle name. And then here we have our getters. Nothing to it. Get ID gets the ID, and so on and so forth. And up here is our constructor, which again takes the input, whatever we send it, the database record or an empty record, and then it keeps certain defaults, and it makes sure that these are strings and all that stuff. So if I run this again, now that my transport is a little bit better, I see success. Browser analyze. Let's have a look. All right, so we do have some issues here, and primarily the issues happen with these guys, the user types, because if you remember in the user types for PHP Stan, we had only the user ID, status, username, and password. Now we have a hell of a lot more, so we definitely need to adjust this. And the adjustment is going to be a little bit different. The user record will have to change. What I did is I made a change this way. Let me just paste it here so you guys can see it. And of course it didn't paste correctly, but all right. So let me just shrink this. So what I did is I actually split it into two things. If you recall, the T user record was either an empty array or an array of this. So what I did is I took this, which in our case is more, and I put it in its own type, and the T user record was either the array or this new type. This makes it easier to set this array shape to different areas later on. And for the transport, let me copy it also and paste it here. Of course the copy didn't work very well, but never mind. We got it here. That's our new user transport. So in our composer analyze, we have no errors because we matched the shapes of the arrays. Finally, while we are in the testing side of things, I'd like to add a couple of tests for the action and also a couple of tests for the responder. If we run the tests here, right, test unit coverage, and we go to our browser and inspect the report, so we're gonna come back. Oh no, we're missing something. Oh no. All right, we're gonna sort that out. If we look at these components here, the report rather, in the ADR, oops, sorry, I was in the domain. In the action, we do have something executing the action handler. And if you click on one of those things, you're going to see that it gets executed by the hello service test and the user service test. when we're dispatching the whole thing. Now that's great, but the idea of creating small classes and classes like little black boxes where you send input and you get output. So everybody heard the junk in, junk out. We need to have a test for that class alone. And that ensures that that class behaves the way we want to. So when the dispatch test will come over, which will be the whole round trip, then that would allow us to be 100% sure that everything works down the line in the chain. But still, we have to have tests for those classes themselves. So for our action here, I'd like to create an action handler test. And that action handler test will be a simple, let me throw some data to you and give them back to me. Now, in order to create this test here, we will need to have a service, because if you recall, the action picks up the service, picks up the responder, gets whatever the service returns, sends it to the responder, and everything comes back to you. We do have services here, but I don't want to rely on any particular service, whether this is Hello World or not. The Hello World will go away at some point because we use it as a testing, as a proof of concept. So what I'm going to do is I'm going to utilize this fixtures folder, and what I'm going to do is under the services, did I move the components up there? Yes. Let me just get rid of this guy. We don't need it. I'm gonna create a test. Another test, a service. So service fixture, and it's not gonna be an abstract class. It's gonna be just a final read-only class, service fixture. We don't need any of that. And important, because I've done this before, we need to come up here, get this, and then paste this, and then fix the namespace, because that's the fixture that we want. So in this fixture, it's gonna of course implements domain interface, and then let's add the stubs. So it's going to return, it's going to receive an input and return something back. It will be a payload, of course. So return new payload and domain status success. And what we're going to return is, in the data node, we're going to return input. So very straightforward. Whatever we send it in, we're going to get it back. Okay. And now in the action here, do we have a random test somewhere? Let's get this. And paste it in here. I just want to keep the doc blocks. Action handler test. Alright, and in the action handler test now, let's call it test invoke. Alright, so what are we going to do here? Let's get rid of all of it and just start from 0 and clean these things up. Alright, so for starters we have the container. So let's get the request, the response, and the responder. Get shared. Request. Response. So responder JSON. And let's fix the doc blocks so that the ID helps us. All right. Now, let's create some random data. Let's assume that we have a get, and we're just gonna dump some stuff in there. Because when we invoke this service, the input class will collect whatever get data we have, and it will send it to the service. So let's say get data equals let's say key, that's no value, let's make it unique, and then key. Spelling is not my best suit or attribute. Data equals an array of, let's say, another one, unique ID, and let's call it data. All right, so this usage of unique IDs ensures that the data is random when the test runs, so I don't get sucked into believing that hello world is always hello world. And what we're going to do is we're going to copy that get data into the get array. So now we're assuming that all that data was sent as a get, and first of all we need to get our service picture, and now we need to get our action handler. And the action handler requires the request. If we see the signature here, request, response, domain, and responder. So we already have the request, response, service, responder. So we have that, and now we need to invoke it, and we need to capture what it will do. Reminder: the responder is sending the response, so we need to use the output buffer to capture everything. Will be start action invoke content equals ob get clean. I'm doing this so that we have imports at the top. PHP Storm does add them up here. And what we need to do now is content equal JSON decode content, data equals content data, errors equals content errors. So what we're gonna figure out is what we need to test is this assert empty errors, and the expected will be the get data, this array up here, and the actual will be data, this assert, same, expected and actual. So our service fixture grabs input and just sends it back. This is the input that we sent, so we expect whatever we get from the data node of the return is the same as this. So now if I run the testing suite, I have an error here. Of course I have an error, because we did move stuff, didn't we? So the tests, fixtures, domain, service, CNV. I just deleted that file. It should be components. So we need .env test. That was an unexpected change that I had to do. So env manager test is here. Fixtures, domain. It's not services, it's components. .env. That should be fine, and we should have something in the .env here. So now if I run it again, I shouldn't have those errors. Excellent. But what we were aiming for is for this file here. So now if I refresh it, this is our action handler. If I click here, now you see at the top here we have the action handler test invoke. So we have one more test that covers this file, and it's the isolated test, the test that isolates just this file and tests this file alone. I want to do the same thing with the responder here. If you notice, this one gets called by the action handler invoke, health middleware, and all that stuff, but it doesn't have a test of its own. So let's quickly do that just to add something extra. What I'm going to do is I'm going to add this to that, and I'm going to call it JSON responder test. Of course, it's going to be completely different, but we talked about this. We're just getting the stuff over here. All right, let's do a test success. That's our responder. And what we're going to do is we need the response interface and the JSON responder. These two. Perfect. So let's get rid of that part. Data content equals unique ID data, whatever, something. I don't want more entropy. I'll leave it as data like that. And the payload, because we will need a payload object, will be domain status success, comma, and this is what we need to send. Code equals HTTP codes, codes in num, okay, value, message will be text, data equals an array of data content, and errors will be empty. If you recall, we made these changes earlier in order to transport data accordingly. So now we're going to start the OB start, and we're going to have output response is responder invoke response payload, and then we're gonna have content equals ob get clean. That's great. And then we're gonna decode the content. Okay, so first assertion we need to make is, let's check the code. Expected equals HTTP codes in num, okay, value, actual equals HTTP response code. This assert same, expect actual. So now we need to check what is this here, whether it was returned properly. Expected equals response interface class, this assert instance of, yes, it will be expected output response. Alright, so we're testing this guy. A little bit of an overkill, but you know, might as well keep everything together. It equals contents meta. So now what we need to do is we need to do a little bit of hackery. What I want to do is I want to get rid of the hash and get rid of the timestamp, because those are the ones that are changing, and those are in the meta. So unset meta hash and meta timestamp. All right. So now the expected equals an array of data content, actual equals data. This assert same. Actually, let's leave that. The error should be empty. And now finally, we're gonna check a little bit the meta and also the headers. I want to check that one that it's set just fine. So remember, from the meta we remove the hash and the timestamp, so anything that remains will be code and message. So expected equals code will be that, and message will be not that but success. Remember, this is the meta message, not the message that is being sent to the with the response. Actual equals meta, and this assert same expected actual. And now what we need to do is we need to get the headers and just make sure that the e tag is set, the status is set, and all that stuff. Headers equals output the response, get headers, and then throw that to an array, and then expected equals e tag. This assert array has key, expected, and headers. Let's copy this a couple times. We're gonna have, it should be HTTP 1.1 200 OK. And then the next one will be status, and the final one should be content type. Alright, so we have those elements, and now we need to check what they are. Equals 200 OK, actual equals headers status, and expected equals application JSON, actual content type, and this is our type. Alright, and also I want to do a failure, and what I'm gonna do is, because this is a longish test, I'm just gonna copy and paste it and run through the whole thing with you guys, just to understand where this thing is coming from. I just don't want to be typing it, for 5 minutes only to get a test. So this test failure here, responder interface, is pretty much the same as the one above, but what we're doing is we're making a different payload. We're sending a different payload. In this case, it will be an unauthorized. Let me just reformat this so that everything is nice and aligned. All right, so the payload is unauthorized, and we're going to send the unauthorized value and then unauthorized text as the status code for our response. And then the errors, we have 1, 2, 3, 4 error content. Error content is a unique ID. So we're doing the same thing. We're invoking it. We're grabbing the response. We're checking that the response code is unauthorized. Unauthorized is what? 401. We're checking the interface. We're checking that we have array errors meta. Again, we're unsetting the hash and the timestamp. We're making sure now that the data is empty and the errors has 1, 2, 3, 4 and error content. We're checking that the meta node of our payload has the unauthorized and the meta message is error. Again, we're grabbing the array, the headers, and now our E tag is there, stat is there, content type is there, but the header here is 401 unauthorized. And this is the text that came from the HTTP codes in enum, and this is the value of that guy here. So the status becomes 401 unauthorized, and the content is application JSON. So let's run the tests here. Excellent. And if I refresh, this is our JSON responder, and I click here, now you're going to see that I have JSON responder test failure and JSON responder test success. So we do have code coverage on these two methods as well. From the looks of it, this video is getting quite long. So what I'm going to do is I'm going to create the next part, which is the security class, and also fix a little bit the enumerations, and then we're going to call it a day on this video. And in the next video we're going to create the JWT class and also add the middleware to handle JSON Web Tokens. Unfortunately, if we're not close to 2 hours, we're getting close to 2 hours, and I don't want these to become really long videos. So let's get to creating our security class and our enumerations. Let's start with the enumerations first. Let's get that out of the way, and also create tests for them and all that stuff. Don't worry, I've already have the test created for them, so it's not going to be difficult to copy and paste and just go through them. So in the domain we have components. So what we're going to do is we're going to create one that's called enums, a new folder. And in here, in this enums folder, we're going to have different ones. So for starters, if you recall, here in the HTTP we have the HTTP codes enum. So let's go and drag this and put it in there. And also we have the routes enumeration. So that one is under providers. We're just gonna put it here under HTTP. Just note that I'm going to modify the README of this repository to point where things are for those that are coming in and just looking at the repository. Of course, I'm going to work on the docs just to make sure that everything is up to date, and hopefully I can publish something in Cloudflare so that you guys can read and maybe embed these videos there if you want to see them there, and so on and so forth. All right, so we passed the enums, we threw the enums over there, which is great. What we need to do though is something I wanted to do for quite a while, but I haven't done it. I want to create an interface. So what I'm going to do is I'm going to put it here, and I'm going to call it enums interface. And this enums interface will have the following. Interface, enums interface. All right. And then this one will extend back enum. Excellent. And the only thing that this interface will have is the method text. And we're going to use text to offer a string based on the option that we have. So in our routes enum, we're implementing routes interface. I'll come back to that in a minute. In our HTTP codes enum, we do have a text, so very easily I can do implements enums interface, and this one now follows the interface, this text. Now the error is a different one. We didn't put that in there, but for those enumerations that have text, we can use the enums interface. Let's go back to the routes enum. Initially, when I wrote this and I create the routes interface, the idea was that potentially this one will be a multi-app API, if you like. So you could have one API that does A and another API that does B, and so on and so forth. As such, you would have different routes for each of those. And all we would need to do is grab our code, centralize it, put it into a big library, and then each of those two applications, by using a different enumeration for their routes, also implementing the routes interface themselves, they would be able to run. But since this is just the one application, I'm just going to get rid of the routes interface. You can certainly add it later on yourselves if you have the need for such applications. So, for instance, we could have had one API application that does just the authentication, all right, just the login, at which point it wouldn't really need middleware. It will just do the auth. And you could have different parts of the application, one that handles the user, one that handles companies, and so on and so forth. So that's where the routes interface would have been very beneficial. But let's take that out. We don't necessarily need it right now. Let's see, where do we have it? Here in the routes interface. So let me get rid of that, and I can get rid of that. Actually, that was not a good idea. Can I do an undo? Maybe. Yeah. All right. Okay. Good. So I wanted to keep this, and of course I forgot these ones as well. So I'm gonna come over here and paste this. And I know I have a reference of this somewhere. I don't remember where, but I do have one. So let me copy these, and we're gonna paste it inside the enumeration. Do we really need the event before and event finish? We're not using the finish, but it's okay. So let's get rid of the routes interface now. And get rid of that. So now it should work. I'm pretty sure it's going to complain, at least in PHP Stan, that there is one reference of T middleware that it doesn't exist, or it's wrong. Yeah, there it is. Router provider. Okay. So it's up here, routes enum. So that's the reference that we had to create. So if we run again, composer analyze, perfect. All right, so we move these enumeration classes here. I want to create also a new one, and I'm going to name this directory common. And the new enumeration will be flags. I mentioned this a little bit earlier. It was with regards to the find by email, and I was saying, you have active and disabled and enabled and all that stuff. This flag, it will pick up enums interface, and what we're gonna have is case active equals 1, case disable equals 2, case inactive equals 3. One might ask, what is the difference between active and inactive? Between disabled and inactive. Inactive could very well be somebody that hasn't logged in for a very long time and the account has been deactivated. Disable is the one that the admin went and nuked them. So one thing to note here, just copy this and make the text correct like that, and like that. I'm gonna leave the malformed payload down there because I want to make a point here. So enumerations are very powerful because they can actually hold one or more states. So you could have a number here, and that's one of the states, and you can access it with value. So flags enum active value. You could also use the text method that we created, and that will return a text for you. In this case, active will return active, but if you had app malformed payload, it would have returned malformed space payload. Okay. But they also keep a different state with certain provisions, and the provision is the name can be only one word. So if I want to get the text from this, I because all these are one words, active, disabled, inactive, I could do return this name, and that one will return either active or disabled or inactive. So this is gonna be it's not gonna be necessary. So depending on your enumeration and how you use it, you could take advantage either the name of the enumeration element, the value of the enumeration element, or you can come down this route and create a text method or others that would help you enhance that functionality. So for this flags enum, in order to see it in action, we have to go to the user repository, and here where it says user flags, we can do flags enum active value. There you go. So now we're using this, and these are our flags enum. Okay, let's quickly write the test for this, just to make sure that we have everything covered. That's that. Not under domain components. Did I put enums under components? I did, didn't I? Yes. Directory enums, and the HTTP codes enum test is under here. We have all of these, and then we need common. And let's put flags enum test. And the flags enum test will be, let me copy it for you guys because we don't want to lose a lot of time. If I can find it where I have the code. There it is. It's here. Okay. And let's import this. Now, the obvious question is, why do you do this all the time? I mean, clearly you're checking every single thing of an enumeration where you know that the enumeration is proper, the way it was defined. If you have an enumeration that is not used to interact with your database, then one could say, yeah, okay, you don't necessarily need to test that, but this particular enumeration and others interact directly to the database, meaning that this active, disabled, and inactive hold states into your database, and in our case it will be the USR status flag. Okay, so by the way, I could have named this as status as well. It's just how you want to name it. Just leave it flags now, change the status, whatever you want. Maybe we'll change it later on. I don't know. It's up to how we move along with this project. But the point is that we're keeping a state into the database. One could turn around and say, well, instead of doing that, why don't you create a state table, a user state table, and then link the two, by foreign key or whatever, and then you're fine. I agree. That is a good way, but for such a small subset of values, it is just a little bit of an overkill to create a join, to go to a different table to do the lookup of what 1 means or what 2 means or what 3 means. We're going to come back to this later, where you can use the enumeration to create a case statement that you can inject into your SQL, and you can get back the name based on a value. But that's a little bit further down the line. For now, we're keeping active, disabled, and inactive, and everything is fine. We have our tests. Sometime down the line, a new developer comes over, and he's tasked to do something else. Well, he comes over and says, all right, well, I want to add a new element here, and the element would be, let's say, cancelled. or no, active, disabled, inactive. What can we do? Enabled. I don't know, right? So let's say case enabled, and that's 4. And then the developer looks at it and says, oh man, I really like to sort things, so I need to move enabled up here, right? Because it's ADE. And then it could very well be, ask me how I know, it says, all right, well, why not sort these also? Okay, by doing this right now and committing this change, the developer managed to change all the inactive employees to enabled. And that is a change in your database that is instant the minute you commit the code. And as such, pretty much people got access to things that they weren't supposed to have access to. So if we do have this done, and we have this test here, as soon as it hits this test, it's going to say, my friend, inactive is not inactive, it's enabled. And inactive here is not 3, it's 4. So immediately it's going to catch you, and you're going to say, oops, that's a good thing that we have that. I'm going to put enabled whatever I want, but I'm not going to change its value. Okay? So that's kind of like a lesson, a hard lesson that I had to learn, that you need to have tests even on these little things. Okay? We have the routes enum as well. The routes enum is here, the routes enum test. So let's throw that in the HTTP there. Okay, so we have the common ones, the HTTP ones. Perfect. All right. So, good organization that we've done. Let me quickly run analyze and the tests. Just want to make sure that we're fine. All right, and I believe we should be very close to 100. What don't we have? User repository and user transport. Oh, okay. Well, we can just change the test a little bit, or we can create a transfer repository test. That shouldn't be a problem. We can add that as the very last thing that we do here. Okay. So transport repository and data source. Oh, we don't have it there. Okay, good. Okay, let's create the security class. And the way we're gonna do it is we're gonna create a new folder called encryption. That's where our security class will be. And let's copy another class and call it security here. And our class, the security class, is going to be an extremely simple class. It's going to wrap two methods, the password verify and the password hash. These are PHP functions. Class security. Let's get rid of all of that. Let's get rid of all of that. And what we're going to do here is we're going to say public function hash string password. I return as a string. And we're not going to use default, we're going to use Argon. Because why not? Creates a password hash using and I need to put a comment here. The algorithm changes let's do something here as well. Private this is what it's string I don't know if I can do this here, or can I do it in 8.3? Right, well, if I remove this. I remember in one of them, you weren't allowed to do it in 8.1 or 2 PHP. So you could change this to self. I'll go. Come on. Why doesn't it take the algorithm? Private. Private const equals self algo. If the element is verb, validate the database. Okay, and let's do a verify. Public function verify, and this one would return password verify password hash, autocomplete for the win. Alright, so this is our component here. We're going to use it to hash the passwords in the database. So because we really want to make sure that we don't have clear text passwords. So back to the container here, we need to create a new security QRS. So it's going to be here. So public const security equals security class. Reminder again, this is just a normal class, no constructor. Um, we don't need it shared. We just use it here. So now that we have the security class, let's quickly create the security test. It's going to be a very easy one. Components, directory encryption, and then paste this security test, and the security test will be test. Really what we're doing now is we're checking something that has already been checked, meaning the password verify and the password hash. But the reason we do this with the hash and verify in a security component is if later down the line, or if somebody that will start using this project, if they want a totally different security hashing mechanism or checking mechanism, they can change that component and everything else will work. So of course they can scrap the component easily. So let's see something. Password equals this get strong password, and I do believe this one restricts it to 128. Yes, it does. Now security equals this container get container security, and what we need to do here is we need to say hash equals security hash password, actual equals security verify password and hashed, and this assert true. Actual run tests, and everything passed. All right, excellent. So we got the security component in here, and now let's have a quick look at the abstract test unit case, because here with this guy we need to make sure that it stores data in the database in an encrypted manner, or hashed if you like. For now we don't have a save in our database, we don't have a user post or something. This is the only insert that we're doing, so we need to ensure that it is here. So let's get the security component, container security, and this one is a security component. And what we're gonna do is we're gonna say password security hash password. So this password here will be hashed all the time. Okay. And is this the only spot, I wonder? Let's run the tests. All right. Okay. The one last thing that we need to do is just add a couple of tests for the transport. And what we're going to do is we're going to create a transport repository class here. And we're going to add, next time, we're going to add a query repository class here as well. So just to make sure that whatever we call we get. Let me just rename this to transport repository test. Yes. And the transport repository test will have one method here, and that one will be new user, transport repository, Okay, what do we need to do? We need to get data. Let's say db user equals this, get new user data with no fields. User equals report. Should we do this? Yeah, transport new user db user. Or actually, no. Let's do an empty first. Get rid of all of that. It confuses me. And then we have to do this assert actual user is empty. This assert true actual. Now we need to do user again equals transport new user db user this time. Full name equals hold on, let me copy it. It's too much typing for a video. Alright, so what we're going to do is we're going to create a transport repository. We're going to call it with empty. Just put this one here, makes it a little bit easier. We're going to call it with an empty array, and then we're going to check if it's empty. It will be. Then we're going to get some data. We're going to throw it into the new user, and then we're going to calculate the full name. This is a method that the transport repository has. So it's the name last, first, and middle. Then we have all these fields here, and this is the to array of it. And then after that, we're testing every single method there is, and including the full name. Overkill, yes. Full coverage, yes, sure. But I'd rather be safe than sorry later on because I made a typo. So if I refresh this now, it's 100% everywhere. And yeah, great. Let's have a quick look at what the composer analyze. Excellent. All right. So, as a recap, what we did is we reorganized the repository by means of action domain and responder. We put the action stuff in the action folder, reorganized a little bit the domain, created components where we put all the components that are required in the for the application, and services we have all the endpoints where we will need the hello user and so on and so forth, and we put the responder in the top folder under the source. We worked quite a bit on the data source. We created a proxy class, if you want to call that, the query repository, which we put into the DI container, and from that we're able to instantiate user repositories by calling the user method. And we changed the user repository to return just an array, not a transport. We also created the transport repository, which again grabs a database record and creates a user transport, meaning that we split the user repository as it was to database operations and then domain operations. And this is what these two classes are. We fixed and added more tests to the repository. We created an encryption we reorganized the enumerations. We removed the middleware to return the response back, and we moved all that functionality in the responder. and that led us to remove the custom response class that we had. So now we're using just unaltered Phalcon responses. And finally, after a lot of tests and code coverage and PHP stan, we created this security class under encryption that allows us to hash passwords so that we can store passwords hashed and not in clear text in the database. In the next installment, we will certainly work on the JWT stuff. We did a lot of good work here. If you notice, in the database, we now have an issuer, token password, and token ID as well as preference. We can utilize the preference as well. But these three fields can be used to generate and authenticate tokens that are being sent. So next time around will be to create the class that will create and parse JWT tokens. We're going to create the authenticate slash login URL where you can post your email and your password and you get data back, the token primarily. And then we're gonna work on validating these tokens and and protecting endpoints by tokens. So you're not going to be able to do a user get if you don't have a valid token. And that is all for now. I did try to shorten it, but still, this is getting 2.5 hours, close to 3. Apologize for that. Until next time, thank you so much and take care.